Hello everyone, our lesson for today is exponential function. What is an exponential function? Now, exponential function involves exponents, but note that an exponential function has a constant as its base and a variable as its exponent, but not the other way around. Example, 2 power x, 5 power y are exponential functions. If a function has a variable as its base and a constant as its exponent, then it is a power function. Let's study the two tables of values that are used to graph the exponential functions f of x equals 2 power x and g of x equals half power x. We will start by f of x equals 2 to the power x. Look at the table. If x is negative 2, then 2 power x is 2 power negative 2, which is 1 over 4. X is negative 1. 2 power x is 0.5. X equals 0. 2 power 0 is 1, and so on. Note that f of x increases as the values of x increase. So if you plot the points you have in the table and graph f of x, you will have the following graph. Now let's move to g of x equals 1 over 2 power x. If x is negative 2, g of x is half power negative 2, which is 2 power 2 equals to 4. If x is negative 1, g of x equals 2. X equals 0, g of x is 1, and so on. So note that g of x will decrease as the values of x increase. As a result, from the above two graphs, we can see that f of x is increasing where g of x is decreasing. In general, and here to be admitted without proof, if f of x is equal to b power x, then it increases when b is greater than 1 and decreases when b is between 0 and 1. Now, one of the popular exponential functions is f of x equals e power x. What is e? E is Euler number. It is about 2.718 and so on, etc., which is greater than 1. So you can deduce that e power x is an increasing function. As a result, for a, b belongs to R, if a is less than b, then ea is less than eb. The order doesn't change. A greater than b, ea is greater than eb. The order doesn't change since the function is increasing. By definition, the exponential function is the inverse of the len function. So len is from 0 plus infinity. The domain of len function is from 0 plus infinity to with range r. The exponential function has domain r and range 0 plus infinity. So since the two functions are the inverse of each other, len of exponential x is x for any real number x, since the domain of exponential is r, and exponential of len x is x for any positive real number x, since the domain of len x is 0 plus infinity, only positive numbers. So len e x is x and e len x is x, here for any real number and here for only positive real numbers. So ex and len x sure are symmetric with respect to the line y equals to x, since ex is the inverse of len x. The derivative of ex is ex, so d by dx of ex is ex. D by dx of e power u is e power u du by dx. For example, if you have e power 3x, so its derivative is e 3x times the derivative of 3x, which is 3. So 3e 3x. And now let's study the variation of Ex. Now the domain of Ex is negative infinity till positive infinity. The domain of Ex is R. So we will study the limits at the endpoints of the domain. The limit as x tends to negative infinity of Ex is E negative infinity is equal to 0. And the limit of Ex as x tends to positive infinity is E positive infinity, it is positive infinity. Now when you have the limit as x tends to plus infinity of a function is plus infinity, you have to study the limit of f of x over x. Now here, the limit of f of x over x is the limit of, limit of f of x over x as x tends to plus infinity is the limit of Ex over x. So it is infinity over infinity in determined form. So use Hopital's rule. So the limit of Ex over x as x tends to plus infinity is the limit as x tends to plus infinity of Ex prime over x prime, which is the limit of the derivative of Ex is Ex, the derivative of x is 1, so it is Ex, so plus infinity, which means that the function has parabolic branch parallel to the y-axis. So the function has a parabolic branch parallel to the y-axis. Now we will move to the table. Okay, now the limit as x tends to negative infinity is 0, which means that Ex admits the x-axis, means y equals 0 as horizontal asymptote, and the limit of Ex as x tends to plus infinity is plus infinity with the limit of f of x over x plus infinity. So Ex admits a parabolic branch parallel to the y-axis. Here we go with the table. So at negative infinity, f of x tends to 0. At positive infinity, it tends to positive infinity with its derivative e power x. You know, e power x is always positive. Its range is 0 plus infinity. So Ex is always positive. The derivative is positive, means that the function is increasing. So f of x increases from 0 to plus infinity. The point passes through the 2 points 0, 1. Why? Because e to the power 0, if x is 0, e to the power 0 is equal to 1. If x is 1, e to the power 1 is e. So let's move to the graph. The function at 0 has the x-axis as horizontal asymptote, or y equals 0 as horizontal asymptote. It passes through the point 0, 1, then it increases, having the y-axis as a parabolic branch parallel to the y-axis.